6.1 Factoring polynomials. Our second objective here is to factor out common terms in polynomials. And we've actually already started doing this, and many of you have seen this before, so it's going to be kind of a little bit of a review. So if we were to multiply these, I would distribute that 5, and I would get 15. No, not 15. I'd end up with 5. 5x plus 15. So going back to factoring, notice that they both have a 5 in common. So I pull that 5 out, and I'm left with an x when I take the 5 out of the first piece here, plus 3 when I divide by 5 on that second piece. So again, if I was to multiply 3a, I have 3ab squared plus 6a. So in this case, they both have a 3 in common and an a in common. So I take that 3 and I take an a and put it on the outside, and I'm left with b squared plus, if I take 3a out of 6a, that means I divide 6 by 3, I'm left with just 2. Looks more like a z. Now if you take the entire chunk out, you still have to leave. So in something like this, where I have x squared plus x, if I want to factor this, they both have x's in common, so I take out the lowest term, so I can only take out one x, and I'm still left with an x in this first term here, but I'm left with nothing in this second term. But it's like I divide, so x divided by x is equal to 1. So I need that placeholder of a 1 left there. So anytime you take the full term out, you still need to leave a 1. Alright. We use the term factored out. So when we go to factor out this equation here, I look to see what the highest term they have in common. Well, they all have even numbers, so I know that 2 goes into all of them. So I'm definitely going to take out a 2. They all have x's, and they all have, the lowest value is this one right here, so that's an x squared, and they all have at least one y. So if I take 2 from 4, I'm left with 2. If I take x squared out, I'm left with just an x. If I take one y out, I'm left with a y. Plus, now I'm here, 2 out of 6. 6 divided by 2 is 3. I'm taking out all of the x squares, so that goes away. And I'm taking out only one y out of 3 of them, so I still have y squared. Plus, 8 divided by 2 is 4. I'm taking out x squared, so I'm left with x squared. And I'm taking out the full y. And this is what our factored out equation would be. We cannot lower it any more than that piece. So here are a few that we can factor. So this first one, they both have the 3's in common, so I'm going to factor out a 3. And I'll have 3 parentheses x squared. And notice I took the entire term here. So remember I said we need a placeholder of a 1. This next one, they both have the 5 in common, so I can take a 5 out. And they both have at least 3y cubed, so I'm going to take y cubed out. So in the first one, I'm left with just y minus 20 divided by 5 is 4. And I took out all the y's because I took out a y cubed. So that's our final answer. This next one, they both have the a squares, and they both are divisible by at least 4. So I'm going to take 4 out, an a squared. And I'm left with 4, and I took the a squared out, so it's just going to be b squared. Plus, divide by 4a squared, and we're left with just 5. Okay, this one we got to look at a lot of terms here. It's all divisible by 3, and they all have at least an x squared. So the first one, when I divide by 3, I get 5, and I divide by x squared, and I end up with x cubed minus, divide by 3 and you end up with 4x squared plus 9x. And I took that entire term out, but I still need the placeholder, so I keep 1 there. Remember, 1, placeholder, we'll call it. So our last one here, a little bit longer. Looking through, it's all divisible by 2. So we have a 2. And they all have m, at least m squared. And they all have an n. So 4 divided by 2m squared n gives me 2. And I'm taking out all of my m squares. So I'm left with n squared. Plus, the 2 goes away, the m squared goes away, I'm taking out 1, so I have just n, plus 6 divided by 2 is 3, and we took out an m and n squared, so those kind of go away, and we have our factored out equation. Alright, so here are 3 different problems for you to try, progressively getting harder. Notice that we're dealing right now with all whole numbers. We're not going to factor fractions quite yet. We'll get there eventually.